Hey everyone, let's take a look at number 2 in section 8.4. In this problem, we're going to find the centroid of the region lying underneath the graph of the function f of x is the square root of x over the interval from 0 to 29. Of course, they mean lying underneath the graph of this function and above the x-axis. So I've drawn the graph of a rough graph of that function. Here's the square root function. By the time we get to x equal 29, the square root of 29 is 5 point something, right? You can, check on your calculator what that is. Of course, at 25, x is 25, the square root of 25 would be 5, so we would be at that height, so a little bit more than 5. Um, so that's the top function of the region we're talking about, and then the bottom function is just the x-axis, or just y equal 0. And so I've shaded in yellow there, if you see that, the region that we're talking about finding the centroid of. And that'll be helpful when we get our answer. We can check and see, does it seem reasonable? Um, so we'll start with computing um, the mass, really, of this region. We're thinking of a density rho, which is a mass per unit volume, or in this case, we'll just say mass per unit area. We can just think of this as this lamina. We cut this out. The thickness of it could be one unit thick. Um, so I'm just going to find the area of this region and multiply it by the density to get the total mass of the system, or of the, not the system, but the planar lamina here. So what am I going to do? What's the area? Well, I'm just going to integrate under the curve, square root of x, which of course is x to the 1/2, from 0 to 29. And that's a pretty easy derivative to evaluate, or antiderivative to evaluate, rather. Plug in 29, and I get 29, I get 2/3, 29 to the 3/2 power, of course, minus 0 to the 3/2 power, which is 0. So I just get 29 to the 3/2 power. And you could leave it as 29 to the 3/2, but it's kind of neat to realize that 29 to the 3/2 is really 29 to the first power times 29 to the 1/2, right? Because I'm adding the exponents here. 1 plus a half is 3/2. So the square root of 29 to the 1/2 is the square root of 29. So I can write 29 to the 3/2 as 29 times the square root of 29, a little bit more convenient form. 2 times 29 is 58. And so I get this expression for the mass. Now I need to find the moments about the x-axis and the y-axis. And here's the formulas that I would give you on a test, for instance. And so we have formulas for uh, the lamina that's bounded by the graphs of two different functions. Y equal f of x is the top function. Y equal g of x is the bottom function. In our case, g of x is just 0, right? Y equals 0. And so these equations here simplify down to this, right? So the moment about the x-axis is 1/2 rho integral from a to b of the function, top function squared. And that's what I have here. And if I square the top function, of course, the square root of x squared is just x. And that's a pretty easy antiderivative, right? It's x squared over 2 is the antiderivative of x. Of course, times 1/2 gives me really x squared over 4. And then I plug in 29, plug in 0. 29 squared is 841. So I get 841/4 times rho. The moment about the y-axis, right, is again x, integrating x times f of x. We derived these formulas in class. So x times, in this case, the top function f of x, x to the 1/2. Again, adding exponents like we were just talking about, we get x to the 3/2. Antiderivative of that is 2/5 x to the 5/2. Plug in 29. I get 29 to the 5/2, and I'll do a similar thing like I did up here. 29 to the 5/2 is 29 squared times 29 to the 1/2, right? 2 plus a half is 2.5, or 5/2. And so 29 squared times the square root of 29, of course, minus 0 when I plug in 0. And so here's my expression. I go ahead and multiply 2 times 29 squared. I get that big number there. And there's my moment about the y-axis. Okay. Now we're ready to find the centroid. So remember, the x coordinate of the centroid is the moment about the y-axis divided by the mass. So here's the moment about the y-axis we just found, the mass we found up here. Right. And of course, one thing we note is immediately the rows will cancel, right? And this is true, right? The density of the material, as long as it's uniformly dense, does not affect where the centroid is located. We might need, if we're trying to hold it up, a greater force for a more dense material. But at any rate, the location of the centroid is the same. In fact, in these problems, you could just assume, for instance, the density is equal to 1 if you don't like to write the density symbol there each time. Uh, the the row, you can just plug in 1 for that, and that will work out as far as finding the um, center of mass. Now, if you need the moment about the x or y axis, you do need to have, the density could be a factor in that. So you want to remember to keep it in those calculations. Okay, and then what do I have here? I have, of course, square root of 29 divided by square root of 29. I can, simplify that. That's 1. So I have 1,682 fifths divided by 58 thirds is times 3 over 58. Simplify this fraction, we get 87 fifths. And then similarly, the y coordinate of our centroid is the moment about the x-axis divided by the mass. Here's the moment about the x-axis that we just found here. Again, here's the mass. Again, the rows cancel here. And I simplify. Again, dividing by this fraction is multiplying by its reciprocal. Do a little simplification there. 29 times 3 is 87. And then square root of 29 times square root of 29 is 29, but 29 obviously divides into 87 3 times. And so I get 3 square root of 29 over 8 as my simplified fraction. And again, I rationalized this. I mean, this again is fine for, if I was giving you the test or something, and I might probably ask you to go ahead and approximate it. This one in Achieve, they want the exact value. So this is what you would enter in. They want it as an ordered pair with X bar comma Y bar. But it's a good idea to go and approximate that because 17.4 is about 87 fifths. Well, actually exactly equal to 17.4. And then this y coordinate is approximately 2.02. So if I come back to my region 17.4, somewhere out here in 2.02, that seems reasonable, right, for the location of my centroid somewhere in here. If you're getting a value that's down here, that doesn't seem right, or somewhere over here, or worse, somewhere off the region, something's not right. So always at least sketch the region if you can, try and do it as accurate as possible if you don't have it already, and that will help with confirming your result. Okay, hope this is helpful.